And there's a scene at the bus stop, which we kind of created. And this previs was created after we'd done a kind of week-long recce in Zanzibar. So we had a really strong idea of the location that we wanted to shoot in. We took kind of reference photographs that we could kind of build really rough base templates for all the environments, or we could kind of camera project onto certain scenes and kind of quickly rig characters up to do certain movements. And you can see here just how, in some of the shots particularly, how similar they are to the final film. And we downloaded a rigged fish from Turbo Squid, and we had some fun with that. And we linked kind of lots of mocap data to the fish and also to the kind of base characters that we were working with. And I'm going to be showing you how to kind of add mocap data to a basically rigged character, and how to blend different mocap data together on layers, and even add custom animation on top of the mocap data very, very easily. So this is where our character's kind of like contemplating setting out to sea to find the fish, and then he sees a splash in the water. And some of it was actually, some of the previs was actually filmed from the characters themselves in kind of like early kind of like tests and character tests. And here we see our kind of character setting out to sea in the previs with our rubbish, and the boat's kind of intersecting the water. And we did lots of different kind of versions of this. So we're not really caring too much about any kind of accuracy or consistency in visually, but we're trying to think mainly about camera and how it's working with this kind of story of the scene. So very easily we've just kind of linked that, and this is obviously going to be, if we invert our selection, we can see that it's actually happening. Let's leave this light. You know, it's all linked with our main character, but obviously we don't want to really work in this mode because we can't see the movement very well. This is where we'll actually start to you know, export the viewport. Drag this back over. We'll actually start to grab our viewport to see this properly, but for now we don't really need to do this. We're not finished with our data set yet. So we can work much faster by working with the bones here and see what the movement's actually doing. This is quite a long mocap set. So what else can we do here? If we go back into our motion panel, you have to click on one of our bones to see anything. Go back into our mixer, which is here. Let's just zoom out of this for a second. So what happens if we add a new track to this? We want it to dance around for a second, and then we want it to run off in a certain direction, say. So let's find another mocap set. Let's see what we should add here. Let's add a jog. And see what's happened automatically is, if we just stretch this in, automatically it's created a kind of link between these two files. When we move this, we can see that that link is editing as well. And what this is a blend between the two sets of mocap. It's automatically clipping our first set when we move our second jog motion we've added here. So let's see what happens when we kind of go to around about this timeline here, where the jog kicks in. Let's see that's happening to the actual biped. Again, it's quite a long frame set, so you can see here our timeline's kicking in here. And then we're seeing that he's stumbling around, and then he starts jogging. Let's increase our timeline. you can see here, that transition, he starts jogging there. And this has actually worked quite well. Normally it doesn't kind of blend quite as successfully as this, and normally to solve that, what you have to do is within our kind of blend kind of clip here, we can edit all different kinds of parameters on how that blends, but we could also quite simply press optimize, and it searches the entire clip for the best transition moment between where the feet are between those different mocap data sets. See, now our timeline has changed, and it's edited our 2 pieces of footage to say that this point here, this exact point here, is the best place for feet-wise for that to change. And we can argue with that if we want, and we can kind of try and change it manually. But this is where the computer is automatically saying, this is the best thing, this is the best place I think that this guy should start running from. I'd say we're happy with that, but we want him to kind of run in a different direction. We don't want him to run off in that direction. We want him to run off in a slightly different direction. This is where our edit panel comes in. We can edit this, and we can manually change our rotation. So now he should run off in a different direction there. So we've got quite a lot of control, even though we're using kind of preset motion information. We've actually got quite a lot of control on how that actually reacts. So we don't have to animate everything. We can just kind of control certain parameters for him to do what we want him to do. And then we can do that for anything. We can do that for walking, standing still. We can have a walking motion and then control him to stand still and blend that with a kind of more of a standing still talking motion. We can do like literally anything. And we use this technique a lot for controlling the animation within Jonah, or the previs within Jonah. You can kind of see where the 2 bipeds kind of collide there, the 2 sets of motions. Well, we can go further than this. We can actually add layers to this animation. So say we're happy with this. We're happy with what our motion's doing here. Then what we have to do is, this is quite unobvious, but we have to kind of right-click our kind of main title of our biped up here. And then we have to go to Compute Mixdown. And what that's going to do, it's going to load the 2 sets of mocap datas and also the blend between them. And it's going to create one data set which combines all 2. And then we have to right-click on that Compute Mixdown, and then we have to go to Copy to Biped. And that's going to add keyframes to our biped. So now if we click on any of the bones, let's just have a look again. Copy the biped. It's quite a lot of frames, and we probably should have tested this with a smaller object, but we'll see what this does when it's thinking about it. But while I'm doing that, I'll actually scrub along. This is actually the full previs of the film, or one of the issues anyway that we created, and it'll kind of give you a great sense of the different scenes and how we kind of set it up. Jeff, do we have sound at all? Might need to go louder. Oh, here we go. Yep. So this is Previs with motion blur, and it works really well. I remember when we did this, I was like, that looks really good. We should do more of that. But yeah, I'll let it play, and I just wanted to kind of stop on that one because it was such a revelation for us. We're mixing that with actual footage, obviously, as well. And the same technique with this one, as I've just showed you. Linking the camera target, following it manually, adding and blending different controllers, different mocap data sets, Even playing with depth of field. Just giving you a sense of how to tell the story. Doing that all at the previs stage. So at the beginning of the film, our two characters have stolen a camera from a tourist, and the tourist is chasing after them. Here we see all of the market scenes. And a lot of this is remarkably similar to the final film. So this one setup scene with the market, we did lots of different camera moves in and around how they run past, following them, static cameras as they're kind of running past. So you're blending a running and a jumping motion. You can see where that transitions a little bit there, but it doesn't matter. It's doing exactly what we need it to. Using images and just really basic techniques, but it does exactly what you need it to.
Yeah, I say we build Buckingham Palace.
And then combining that with kind of dialogue tests and things like that. I won't show the whole thing because this is the full film in previs at this stage. But it's just good to see different scene setups, simple camera projection and backgrounds that are put in. Camera projection in the same way.
That is good thinking.
So I can kind of scrub through this, and we can see some of the different scenes that we set up. This is on the pier with a fish. As a fish jumps out of the water. So you can see that motion, that element here. Changed a little bit in the final film, that one. But then we get to the kind of transformation sequences. It'd be quite good to show some of these ones. So again, simple animated collages of the kind of beaches with the rubbish, using mass effects to drop rubbish into the sea. These bits actually we didn't stay in the film. It was slightly too ambitious for our underwater shoot to incorporate a lot of these elements. We had this quite ambitious shot, which we had no idea how to film. Fish turning into signs. It's going to be a bit tricky, that one. Lots of different purposes, but for us it was this kind of magical transformation of our Zanzibar stone town. And then this is the final shot. So, first step in this process was obviously tracking. And there's a few things that we can set up. We're going to be talking about how we did all of these different things. So this is our kind of, this is our PF track window. So let's talk first about the kind of interface of this thing, because it can be quite alien to a lot of other softwares that we use, and it works very differently as well. Anything that's not attached to a kind of fixed point and that have a reference like this, where it could slip along that point, it's good to just check. He's kind of attached more to the hinge, so he's okay. And again, this center view is really great for kind of checking all your tracks. So again, you can see this one visibly slipping. And it's very short, he's a useless track. A lot of the ones on this gate are fine, because that's a fixed thing. It's quite contrasting. We can leave those in there. But again, anything that's kind of along the, in front of that and attached to it, we need to delete. All the ones on the left there are good. We have a moving, dancing one here, which we want to delete. Dancing one there. And again, when you're deleting all these tracks, it doesn't necessarily mean the solve is going to be any better, because you've got less data to work from. So it's that combination. He's rubbish. It's that combination of got a good accuracy and amount. And if you haven't got enough once you've deleted, because you have to delete so many from a shot like this, when you've got a huge amount kind of covered by our characters and then lots of kind of intersecting surfaces, you might not be left with enough tracks to actually, the camera to be able to understand that solve. So that's again where the manual trackers come in. Okay, we have another quick question in the room here, so we'll just get the mic.
I was just wondering when you the reason why you're not working with mask, because you don't want to redo the auto track again and allow it to refocus on the amount of points on the.
Redo the auto track. What? Sorry.
Yeah, I thought the idea of using masks were that you would refine it like you're doing now, basically, but you would refine the mask instead, and this way you could redo the auto track.
This way you don't have to redo the auto track. The auto track, you've already created the auto track, and you're just deleting the points that are tracked. So it's a preference thing. You can either create a mask at the beginning and then auto track, and then it just doesn't take into account anything that's inside that mask or outside the mask. You can invert it. Or you can just track it and then just go through and delete the points like I've been doing. For me, for most of us in the studio, we prefer just manually going through and deleting things, just because it takes quite a long time. Actually, it looks really quick to actually just generate that mask and to track it in, but it can take some time to get that Bezier to be kind of tight enough around your character that you're not ignoring some good points, basically. Because I need every point I can get in a shot like this. I don't want to ignore points that are maybe good, because I know I'm going to be limited by a very few amount of points. So for me, the most detailed way of tracking this shot would be to delete all the points within the characters manually. And I know it's only like 200 frames or something like that, and I can do that, I think, in equal to, or if not faster than creating that mask. And I think the results are more accurate because you're deleting very specific points, basically. It's a preference, you can do it either way. Some people create really complex roto masks and then import those and have that separately. But for this, it was just as easy to kind of delete the points, basically. So, but you don't have to retrack now that you've deleted those points. You just have to resolve the camera point, and that's how you get the camera to be more and more accurate. Is to keep going back, altering the auto track, adding manual trackers, and then resolving the camera. Does that answer your question? So let's just have a look if there's any other points that we are struggling with. And we can see visibly. And then we'll do another solve and see if that's changed anything. Again, we might get unexpected results because we are deleting a lot of trackers here. So we might not have enough data to generate our solve properly. I mean, this one's, what is this actually tracking? Nothing. Yeah. So it is a very fine comb operation when you're kind of dealing with tracking markers and points. But the results kind of speak for themselves when you do spend enough time on things. And the thing is with tracking, it's either right or it's wrong. It's not kind of right. As soon as your kind of model slips, you've lost that illusion that you're trying to create when you add digital elements to real footage. You have to keep the audience completely fooled by what you're doing. You can't have a moment where they realize that it's you know, digital fabrication. Again, this one's slipping. Some of them are more obvious than others. This one's dancing around. And you can already see points when you wish it was tracking, and you can kind of go through and manually track those. That one's slipping. There's a huge amount of errors in this in this scene. Again, sometimes you do get lucky. Sometimes you track something, you auto track, your camera solve, and it's done. And then you can rejoice because you don't have to spend 3 days doing it again. Again, this whole shot, we probably spent 2.5, 3 days on this track shot. You know, one person, 2.5, 3 days, getting it right. It's not something that when you do it properly is easy or quick. One thing to kind of remember is sometimes there's different kind of levels of kind of production for these kind of things. The highest level of production, if you're working on Iron Man 3, they will digitally scan this area, and they will have a completely one-to-one accurate model of your scene, which they'll kind of simplify and create their own version of, and then they will essentially using lots of different methods that I really haven't explored much, but you can import your model and use that as a base for the solve, so that you're working from completely accurate digital information to aid in your tracking markers. That's the complete high end. Well, and then there's kind of another process still, like Cloverfield, for example. You've got digital tracking markers which are read by lots of different cameras in a scene, which will then kind of give you position data no matter what you're doing with your camera. Because if those of you who have seen that film, it's all filmed on handheld, and there's no way they could ever track that like this. So there's different levels of production with these things. The kind of next level is to kind of measure everything and create the model yourself, and then get all texture information from photographs and model up a completely digital version of this based on the old school measure and photograph methods, and then you can still use that. But for us, we didn't have that opportunity. We had to get in and out of this space quite quickly. This wasn't a closed area. This was us, you know, with a few local fixes trying to stop people walking in, and we didn't have time to kind of measure and photograph everything. So you're stuck with having to do everything in post-production, which is most of the time you'll be in that situation. So I think we've cleaned this up quite a lot now. Let's just have a look at some of these. A good thing to note if you're kind of working with a lot of distance things, although there's these points are probably okay, but if you've got things that are very far in the distance, you want to delete those. If you've got things that are in reflections, you want to delete those, like reflective points. That, again, these are all things that fool you into thinking that the points are okay. But reflective points, obviously, want to be getting rid of. We've got no issues with reflection in this scene. But some of the points, like if we had a point down through here in this space, we'd probably want to delete the ones that are in here, because that's in a completely different plane to this building here, and the camera might not read it as such with a camera move as subtle as this around that corner. But that's actually like, 20 meters away from this building. So those kind of areas we want to kind of delete. Intersection. So it's just knowing what to look for. Like, you can see straight away when we're looking properly, this point again is not a good point. And we can see here now we've brought in our camera and all of our tracking data, basically. It's created keys for the entire clip, because our entire clip was much longer. Our original footage that we used. So we can just, because we've only done this as a test for our tutorial, we can limit our frame range to be 648 as it is here. Delete a few keys and just make our timeline 648. You also want to check at this point that you're in the right time configuration, because for us we obviously use 25 frames per second. And you want to just see what that's doing to your frame ranges. So it's automatically changed me to 540. As you can see here, we want to make sure that everything is within our clip. So what we want to do is obviously import our footage in the background. So we'll bring in, we'll go to Control B, or Alt B rather. This is changed in 2014, but I'm sure we'll be able to find our footage. There we go. This is slightly different. Let's load our JPEG sequence. And display background. Again, this is slightly different to one I've used before, but should be the same. There's normally a show background in 2012. Does anyone know where show background might be in this new 2014? Oh. Seems to have popped in. But out of interest, where is it? Just getting some help from the audience here.
The plus sign at the top, I believe, the viewport, I think corner of the viewport. New computer viewports. And then it's going to be background.
That's the same. It's the same place. Yeah. Normally there's like a view background option where you can kind of uncheck and check. Is that moved now in 2014? Right, I guess you just switch between these to turn that on and off, I guess. Well, it's just a slightly different workflow. Okay, but what we do want to do is make sure that we're starting our map at a certain time. So let's just check this, because it clearly is not starting quite at the right time here, and it's exported the entire clip, whereas we had a very specific frame range. So we want to kind of go into our viewport and then start tweaking with this. We wouldn't have this problem if we exported exactly the same clip as we tracked, but because we tracked a different frame range, we need to kind of offset our footage a little bit. Let's just see if that is actually changing. So that's kind of gone back from it. So we want to start this. Let's make our viewport start at 0, so we can see what's going on with our background. Now I'm not appearing.
Instead of dragging the timeline slider, actually try clicking on the arrows on the slider, and it sometimes forces it to update.
I use the curve editor a lot when I use with backgrounds, because it kind of allows the viewport to update with the slider. If you kind of move the slider on its own, you're just moving the model, you're not moving the background. But in the curve editor, you're actually moving the background as well. So it seems to be starting from there. Let's just double check our export to see if we've got what frame it's actually starting from. So you can see it's actually starting from the wrong frame range. And this is because we essentially had a custom frame range in our viewport that we were working to, which was different to our clip. And what we really wanted to do was start from how that synced with our the frame range that we're working with in PFtrack, the same as our export. So what I'm going to do is bring in the one we did before. So load this one. And the distortion might be slightly different on this one, but you'll get the idea. So if we go to the background again, load our previous sequence, press OK. Let's just double check this. And again, this was generated from a slightly different track. So let's offset. See what happens when you start it on 0. See here, it's not kind of matching up just yet because we need to kind of make sure that we've exported the right frame range. This will take a little bit of tweaking if you haven't, if you're, again, your track that you've exported from PFtrack is on a different frame range from what you're actually exporting. So this is kind of starting from frame 340, but our original frame range of our footage, if it will update, PFtrack taking a little bit of time again. So it's just important to be on top of your frame ranges for the kind of export of these things. Let's just double check our curved footage. See, we actually worked from a completely different frame range in our original track. We didn't actually see the foreground element, and we're kind of starting from much further in. So it will be a bit tricky for me to actually match our old footage into our new track because the frame ranges were completely different. So this was a project I did in my Masters, which utilised heavily the thinking particles technique that I'll be showing you. So the kind of tests I was talking about that really inform a lot of the kind of technique development. They start off very simple, testing different kind of fluid simulations and material properties and kind of the way that soft body systems work. And a lot of this is just tested. This particularly was in RayFire. And just general, we do a lot of just general technique testing really. We try and kind of choose internal projects which turn our technique testing into something more. So it's not just for the sake of technique like it is here, but it's actually developing a project that we want to kind of explore within the studio, which happens to use different techniques that we haven't tried yet. But it's just being really active with kind of learning new things all the time. And what I'm kind of showing you this afternoon will be kind of a combination of lots of different kind of animation techniques. Mainly within Max, using lots of different plugins and systems. And just to kind of give a kind of stronger library of different kind of animated assets at your disposal really when kind of coming to any kind of project. Specifically, a lot of the techniques are really suitable for animation within architectural visualization and transformation of buildings and elements of buildings, which seems to be quite popular. And a lot of the techniques I'll be showing are specifically relevant to how we made the street scene that we tracked earlier on today for Jonah. So again, we do lots of different technique testing using various different programs. We have another one here, which is focusing more on kind of particle effects. I'll turn the sound down. And this was basically produced while I was figuring out how to create the film Somewhere, the Golden Age Somewhere, the sequel to the one I just showed you. And that film was incredibly challenging. So there was a lot of different kind of concepts I wanted to try and show, and it was just finding the best kind of technical means of doing that really. I think that's the best way to kind of start projects. You shouldn't really do a project to explore a technique, but do a project to explore an idea and then find out which techniques are most appropriate. So I was looking at all sorts of crazy things at this point. I was looking at the resolution, like representing the resolution of kind of synthetic objects, and looking at how to kind of transform between a kind of like deRezzed version of one object to another. Explored that in a really complex kind of setup, which was kind of linked to camera targets, which would kind of drive the transformation. That proved to be too heavy to even begin to render. I think the light cache just laughed at me for this one. So it lives in previous form. I was messing around with a lot of PFlow sims and using Krakatoa and Fume effects, and how they can kind of work together. Just to drag this guy in, and then you can just select a random amount of objects in your viewport, and then we can just literally play with kind of like these keys so that we're moving and offsetting the animation. What we might need to do, however, is select the slice and make it unique, because otherwise we're only making the offset of the rotation of the object unique. We're not actually making the slice rotation technique unique. So we can keep the object as an instance, but not the not the actual slice modifier. Let's move these guys, the ones we had selected, back. Random select. And then we can move things a bit more. And we did this for a few things. We did this for the rubbish scene in Jonah, where all the rubbish kind of piles on the beach. And what we used it for there was kind of to random select all of the rubbish and then offset the transparency of the rubbish so that it was kind of appearing. It had a dappled effect to the appearance of it, and that meant that it was kind of like flickering in almost. So if we go to the object properties, for that purpose, we animated the visibility from 0 to 1 over 1 keyframe for all of the rubbish, and then selected random select for however many objects were in the scene, 20%, 10%, whatever, and then kept doing that until we had a very natural kind of flickering effect appearing. So you can kind of keep going with this and offsetting things subtly to create quite cool animated effects. So yeah, that's quite a cool effect. So again, starting us off easy, that's quite an easy one, but it produces quite interesting varied effects, really good for facades and windows and things like that, when you're kind of animating different things in the scene. Let's do a save on this. So, looking at this next file, what this was a kind of manually constrained animated sign, which was kind of linked through dummies and point constraints and things like that, to give us this sign which kind of folds out of itself. And we use this in that street scene we just showed you. And the setup of these things are relatively simple. It's essentially kind of linking one object to the next, so that the animation or the scale of it is kind of like parented to its adjacent object, but then also having fun with manual keyframing and linking things with points and dummies rather than actually animating the object itself. And the benefit of that is that you can kind of create an animation and then swap it out for different objects later on, or if you go into more detail later, which is, once you're in animation phase, is probably less likely, but it gives you that flexibility, and it's kind of a good way to work. So if we take a scene, we create some simple geometry. And what we can do is we can start linking and constraining things just get this out of transparency mode. There we go. If we select some points from the helper menu, and we can kind of align that. Align it to our center and then just move it across over here to the bottom there. If we link our object to our point, then whatever we're doing to this object, to this point here, is going to animate through to the object. And it's much, much better than kind of changing the pivot points of your objects manually and then moving them and things like that. You can control exactly where your kind of constraints are and what you want to do with them, basically. You can kind of unlink your selection and move your object again, or your point again rather, and then relink. So what we can then do here, if we actually move this to, if we want everything to be constrained by this one guy here, if we actually just move the point to the other side, and then we animate this guy, say animate him 90, then we also animate the scale from where that keyframe is to 100 to 0. Then we've created a movement like this, and everything is kind of constrained through the point. So let's just let's kill the rotation actually. Let's leave this guy just scaling. Now, to kind of make this simulation a little bit better, I mean, we have a few things kind of popping around. It's not too bad, but if we wanted to kind of like make this slightly more accurate so that objects are colliding a bit more accurate, or they kind of come to a stop a little bit sooner, the settings within the physics system kind of add to that. And this is similar-ish to how physics works on its own, or Mass Effects works on its own. So we can change our collision tolerance. This will basically say between materials how close their kind of RayFire mesh that it kind of puts around it allows them to kind of collide. So this is on 0.1 of a meter. Maybe we want to put this on 0.001, and that's going to be much more accurate. Might take a little bit longer to simulate. And then our sub-steps, again, this kind of setting is really dependent on what is happening or wrong with your scene. So sometimes 3 works fine. Sometimes you want to up this. And essentially what this is doing is how many times RayFire is calculating your meshes between frames. So between frames 0 and 1, it's going to calculate 3 times. And we can kind of up this to, say, 7. You don't want to go much above 10 for these things. And sometimes the higher you go, actually, it doesn't give you better results as you might think, because it's kind of overthinking each kind of calculation, and sometimes you just need a simple effect. So if we unbake this, and we also change because we've got 2 depth levels, we can change the probability of that second smash, so we can change that to 30% probability. We have minimum size limits here, which isn't quite accurate because the minimum size definitely is not 1 meter. So when we bake that now, there's less secondary collisions that are happening. But what we've got is, the first time we did this, we had objects kind of pinging out. They were almost by that initial impact, because they might have had a slight kind of intersection with their kind of like skin that RayFire gives them, they might kind of have more of a kind of force that's kind of pushing them apart from each other. Because if these kind of invisible skins kind of at all intersect, then RayFire tries to push them apart, and you can get some unwanted kind of like unwanted kind of effects of objects kind of pinging off and flying away in unnatural ways. So you can control that mainly with the collision tolerance and the substeps. A few of the settings while we're in this mode, if we delete that again, what we also have is gravity and timescale. This becomes really interesting because gravity, what they suggest is that you always work on a slightly lower than realistic gravity. One for reliability purposes, and that's what they say themselves, but also to create your simulations just looking slightly better. Often when you use this in absolute real time, I find it's a little bit fast, and lowering that to kind of 0.8 or even 0.7 can kind of give you better looking simulations. It's kind of a stylistic thing. Timescale is really interesting because what you can do is you can bake, pause, change that to 0.3. Let's extend our simulation to 200. And then continue the animation. So this is now generating a lot more keyframes for this simulation. Pause, and then let's stick this back on 1. Continue. Let's kind of stop it there. Hopefully that's done what we expect it to do. Yeah. So you can see there, it's kind of, we probably want to extreme the effect a little bit, and let's also increase our time range to 200 in here. For the sake of speed, I'm going to adjust this to be back on 0.05 perhaps, and our substeps back on 3, so we can kind of illustrate this slightly better. Let's delete our frame. So let's bake this in, pause, turn this on 0.1, continue. So you can see that by changing our settings, we've actually created a different effect, which is not quite as reliable, I'd say. Extend our time frame. Also in RayFire. And let's then continue the simulation. We didn't change it to back from 1. So essentially, you get the idea. It's kind of freeze framing more there, and then if we animated the time frame back up, it would kind of go back to time 1. And that's useful when you're doing kind of bullet time stuff, where you want to fly around the camera in a kind of dynamic way. You can really slow this down. So that was done in a simple cloth sim, constraining points to the base mesh, and then creating nodes within the cloth sim to attach vertices of this mesh into onto those points, basically. So you're constraining the points to the mesh, and then you're constraining the vertices of the poster to those points. And then with the wind effect, you create quite a realistic mesh, which is kind of taut. So I'm going to save this, and then I'm going to open up a few other files, which is using, again, 2 other kind of particle systems within Max. One is a kind of feature which is now built into Max. It used to be a plugin called Box 2 and 3, which is a PFlow plugins. But now in 2014, it's kind of part of the base settings within PFlow. Deflectors are kind of offset in their animation. So we can see here that the keyframes down here that are offset by I think about 5 or 10 frames on each one, so that the collision test operator only starts when that deflector goes through that system. And by offsetting it, you can create this quite dynamic kind of like appearance of this kind of girl sign here, which we did. And we've used this since in other applications as well, because again, once the kind of initial R&D was done on creating this this system, then it's very easy to kind of replicate and swap out, because we have different different objects attached within each of these data sets, but everything else is more or less exactly the same. So again, I think with this one, it would have taken too long to do this live in the class, but the benefit of this is that we're giving this away within the set, so you can actually go with this file, pick apart what everything is doing, and you can kind of understand it for yourself and try and understand what the scale and the keep apart and the go to rotation, what their purpose is for each thing. So again, once you kind of get a bit more familiar with some of the aspects of PFlow here, then it will be a lot more obvious of what's going on, and it's actually not that complicated. So what I also want to show you is a really cool effect that we used in the Golden Age film. I wanted to illustrate how it kind of can be combined with Frost and introducing you to Frost very quickly. So let's unhide our, or let's just add our Frost node in, another one. We've hidden our other one. So as soon as we click on Frost up here, it's going to mesh automatically what we've got attached to it, and that'll be we can add PFlow, we can add thinking particles, and we can even add real flow meshes and things like that. And the way we use Frost mainly is either for meshing particles like this that we want to have completely in control in Max, or the way we've done it is when we've done a real flow sim and we've kind of generated our base mesh, our splash and foam particles separately, and we want to mesh them slightly differently, and we want to have that control within 3D Max rather than having to stick with what we export from real flow. So this gives us a huge amount of control, and when you're doing kind of splash and foam on base meshes, you normally kind of work with different materials in each set. So you'll have the base mesh as kind of a water material, you'll have the kind of splash and foam as a slightly more opaque white material, and that will give you a kind of the kind of splash and foam effect when you're rendering. So anyway, we've got lots of settings we can kind of mess about in here. So we can kind of add more particle effects. With here we can see our thinking particles is linked here. We can change the way that the object is meshing by going to the meshing parameters and changing this to geometry. We can change this to be any kind of object we want, but it's currently set to plane. We can custom pick our own geometry. We can select box. So we have a kind of a particle emitting a box, which could be quite a cool effect. We can do so much with simple meshing parameters within Frost. Let's have a look what else we can do here. We can change the scale of our geometry. Let's just have a look at the scale parameters. You can sync this by time or lifespan. You can have them grow over time or born at a certain size and they kind of fade. They fade.